Welcome to Section 11, Lesson 9. Quadratic equations describe many real-world situations. The two most common are projectile motion and optimization problems, both reduced to finding either the vertex or the roots of a quadratic. Projectile motion gives the height of a thrown or dropped object as a quadratic in time. The negative leading coefficient comes from gravity, which is 16 feet per second squared in imperial units, or about 4.9 meters per second squared in metric. Optimization problems set up a quadratic that models area profit or another quantity and ask for its maximum or minimum. The vertex of the parabola gives the optimum value with the input that achieves it. Today's two examples cover both. The first is an optimization maximize the area of a fenced rectangle. The second is a projectile find when a thrown ball lands. The projectile equation, h of t equals negative 16t squared plus initial velocity times t plus initial height. The negative 16 comes from half of gravity's acceleration in feet per second squared. Suppose initial velocity is 64 feet per second and initial height is 0. Plug in to get h of t equals negative 16t squared plus 64t. Find the maximum height. The vertex t coordinate is at minus b over 2a, which is 64 over 32 equals 2 seconds. At t equals 2, the height is 64 feet. That is the peak of the trajectory. Find the landing time, set h equal to 0 and solve. Negative 16t squared plus 64t equals 0. Factor minus 16t times t minus 4 equals 0. Either t equals 0, the launch, or t equals 4, the landing. The ball is in the air for 4 seconds total. Example 1. You have 100 feet of fencing to enclose a rectangular garden. What dimensions give the maximum area? Perimeter equals 2L plus 2W equals 100, so W equals 50 minus L. Express area as a function of L alone. A equals L times W equals L times 50 minus L. A equals 50L minus L squared. This is a quadratic in L with a negative leading coefficient, so the parabola opens downward and has a maximum at its vertex. Find the vertex. In standard form, A equals minus L squared plus 50L. A equals minus 1 and B equals 50. L at the vertex is minus B over 2. A equals minus 50 over minus 2 equals 25. The maximum area is at L equals 25 with corresponding W equals 25, a square. Area is 25 times 25 equals 625 square feet. Example 2. A ball is thrown straight up from a 64-foot roof at 48 feet per second. When does it land? Set h of t equal to 0. Negative 16t squared plus 48t plus 64 equals 0. Divide every term by negative 16 to simplify t squared minus 3t minus 4 equals 0. Factor. Two numbers that multiply to negative 4 and sum to negative 3 are minus 4 and 1. So t minus 4 times t plus 1 equals 0. Solve. T equals 4 or t equals minus 1. Reject the negative time as physically meaningless. The ball lands at t equals 4 seconds. The graph confirms the height curve crosses the t-axis at t equals 4 and stays above 0 for the entire flight. 3 takeaways for quadratic applications. Projectile motion uses h of t equals negative 16t squared plus v0t plus h0 with units in feet and seconds. The negative coefficient on t squared is half of gravity's acceleration in feet per second squared. Maximum or minimum problems are vertex problems. Set up the quadratic that models the quantity, then find the vertex's input value and output value. The vertex is the optimum, the input is what to choose. Always check whether candidate solutions make physical sense. Negative times, negative lengths, or values outside the problem's domain must be rejected. Quadratics produce two algebraic candidates, but real-world problems usually accept only one of them.